so one more even shorter video. As usual, we can turn this whole situation around. If we already know what we want the error to be, we can go back and compute the size of the sample we will have to take to get the error no bigger than that, assuming we have a certain confidence interval. So there are two formulas that we can use. If we already have a preliminary estimate for P, we can use this formula. This is the better one. If we don't have a preliminary estimate for P, then we can use this one. So we use this if we can. We use this if there's no preliminary estimate already existing for P. So let me illustrate what I mean. Let's go back to the previous problem where we had already worked out a 90% confidence interval for this treatment for the skin condition. And we decided that the treatment for the skin condition worked between 70 and 80% of the time, 0.7 and 0.8. And the way we got that is we took our p hat, 0.75, and we added and subtracted our error, 0.05, which we had to work out. So 0.75, this was our best guess, and then we went down a certain distance and up a certain distance, and that gave us between 70 and 80%, 0.7 and 0.8. So we already have a preliminary estimate for P. And what we want is a narrower confidence interval. So what happens if we still want a 90% confidence interval? So still 90% confidence, but we're not allowed anymore to have this much variation around our 0.75. We want it to be, instead of 5% up and down, we need a more accurate answer. We need to know it to 2% up and down. So how big does our sample size have to be? If 5% is no good, instead we want 2%. So obviously we can't do that with the same sample size we were using before. It's going to have to be a bigger sample size. We already have a preliminary estimate, so we're going to be using this. And we're basically all set to go. N equals our initial guess, which is 0.75. This is our preliminary estimate. And then we want 1 minus 0.75. And then we multiply by ZC. For 90%, ZC is still 1.645, all over the error that we are hoping for. So the error that we're hoping for in this problem is 0.02. And we square that. And this works out to, let's see, this works out to 1,268.4. And as usual, we round up. So the minimum size for our estimate is going to be 1,269. That's how big our sample size would have to be to guarantee that we know our P within 0.02 up and down.